So today we're looking at time, and we'll go straight into defining what time is. And by definition, time is an interval between the start to the end of an event. Okay, there we go, that's our definition. And in physics, we measure time in different units, and the following are the units in which we measure time in. After defining what time is as the interval between the start to the end of an event, we have units in which we can measure time. And we can measure time in the following units. We can measure time in seconds, we can measure time in minutes, we can measure time in hours, we can also measure time in days, and the list goes on. But for the sake of the exam, you need to know these 4 units of time. Now, it's very important to know, like we've looked at in our previous videos, that in order to do calculations is what we call standard unit of a physical quantity. So for this physical quantity time, the SI unit, the standard unit, is second. So every time you do calculations, you should make sure that your quantity of time you are actually dealing with has to be stated in seconds. We'll see in our later examples what we mean by that. The fact that we've looked at the definition and we've looked at the units and the SI unit of time, we're now going to go a step further and look at the instruments that we can use in order to determine this time, the physical quantity. So our first one is clocks. We can measure time using instruments known as clocks. We can measure time using instruments known as watches, and these come in different forms: stopwatch, wristwatch, and so on and so forth. Apart from this, there is also another instrument that is known as an hourglass. An hourglass is also another instrument we can measure time in. And the most important one that is usually asked in the exam is what we call a simple pendulum. Okay, a simple pendulum is yet another instrument that is used in order to record time. So we're going to discuss in detail what a simple pendulum is and how we can determine time using a simple pendulum. Okay, so the fact that we've looked at the units of time, and we are now moving a step further to look at a simple pendulum. And before we look at what a simple pendulum is, it's very important that we relate the units of time. So in the exam, you are supposed to convert from one unit to the other, especially from other units to the SI unit, which is second. So the following shows the relationship. Okay, so in this table we are showing that in 1 millisecond we have a total number of 0.01 seconds. So we need to know that 1 millisecond is equivalent to 0.01 seconds. And in 1 minute, we have a total of 60 seconds. And in 1 hour, we have a total of 3,600 seconds. So you will need to relate the units of time and know how to convert from one unit to the other for the sake of the exam. Now we have what we call a simple pendulum. A simple pendulum is an instrument, like we've already said, that is used to measure time. And how does a simple pendulum looks like? This is how a simple pendulum looks like. So a simple pendulum is actually an instrument that is made up of a string very thin string like that, and one end of the string is tied to a small mass, and this mass is known as a bob, and the other end of the string is tied to a fixed position where the object, the string alongside the bob is to swing back and forth under the influence of gravity. The simple pendulum will swing back and forth between two positions, and so this is its mean position, and it will swing at position A, and it may swing at position B. So a simple pendulum will swing between two positions, position A and position B, and this is stating or showing its mean position for its swings. So you need to know what usually happens if a bob swings between position A and B. You need to know the number of oscillations it makes. So in looking at that, we are going to discuss further in detail how a bob will swing from one position to the other and the number of oscillation that it makes. So we have our simple pendulum here showing the positions which the bob can swing between. So we have position A and position B, for which this bob can swing between. So we are going to call this position as the mean position before the bob swings, and it can either swing to position A or to position B. So we need to know the number of oscillation the bob makes as it swings between positions A and B through O. Now, the first one we'll look at is when the bob makes a swing, or in physics we call that swing an oscillation, so we will be using an oscillation instead of swing. So when the bob makes an oscillation from position A to position O, then we'll say that the number of oscillation it has made is equivalent to 1/4. So from position A to position O, the number of oscillation is equivalent to 1/4 oscillations. Only from position A to position O, only then can we say the number of oscillations is 1/4. And when the bob swings or makes an oscillation from position O to position B, from O to B, then we say it's still 1/4. From A to O only, it's still 1/4, and from O to B only, it's still 1/4. Then we can conclude that from A to O to B, the number of oscillation made is 2/4, which can be reduced further to 1/2. And then if the bob swings or makes an oscillation from A to O to B and back to position O, say from A to O to B then back to position O, and the number of oscillation it has made is equivalent to 3/4. So if it swings only from A through O to B and back to the mid position O, we say the number of oscillation made is 3/4. And the last one is when the bob swings from position A to O to B, back to the midpoint, and then back to where we started from. So A to O to B, then back to the position and back to A. The number of oscillations made is actually one complete. One complete oscillation is made when the bob swings from A and back to the position where it started from. So in conclusion, we can relate how a bob swings between positions A and B. If it swings from A to O only, we say it's 1/4 oscillations. If it swings from A through O to B, then we say the number of oscillations is 2/4, which is the same as saying 1/2. And if it swings from A through O to B and back to the mid position, we say the number of oscillations is 3/4. And finally, if it swings from A through O to B and back to the position we started from, we say the number of oscillation made is completely 1 oscillation. So that's how we can relate how the bulb swings between position A and B. Now we're going to look into two terms that are important as we talk about simple pendulum, and these are the pendulum, the period of a pendulum, as well as the frequency of a pendulum. Okay, so now we are looking at the terms that are associated with the simple pendulum, and there are two important terms that are associated with a simple pendulum. The first one is known as period of a pendulum. As a student, you need to know what is meant by this term, the period of a pendulum. So to define this is the time the bulb, this is the time it takes for the bulb to make a complete oscillation. That's what is meant by period of a pendulum. So this is the time it takes the bulb to make one complete oscillation. Like we saw what a complete oscillation is, so we should relate to what this means. So because it is the time it takes, we measure the period of a pendulum in units known as seconds. So that's the SI unit for period, it is second. So, and in order to determine the period of a pendulum, you need to know the formula that is used. So this is the formula that we use in order to determine the period of pendulum. So the capital T in the formula represents period measured in seconds, and the small letter t actually represents the time that it takes the period bulb to swing between position A and B through the mean position O. So this is time taken in seconds. So the time taken can be in minutes, can be in hours, so on and so forth, but it's important to convert that to seconds before you make calculations. And the N in the formula stands for the number of complete oscillations, or rather the number of oscillations the bulb makes. So the number of oscillations. So that's about period of a pendulum. It's, in summary, it is the time it takes for the bulb to complete an oscillation, and we measure period of a pendulum in units known as seconds, and this is the formula which we can use to determine the period of a pendulum. We say capital T is equals to small t divide small letter n, where the t is the time it takes for the bulb to make several number of oscillations, and the n is the number of oscillations that it makes. So in order to determine the period of a pendulum, you need to allow the bulb to complete several number of oscillations and record that as n, and then you need to take down the time it takes for that number of oscillations, so that will be your t, and then divide n into t to determine the time it takes for the bulb to complete only one oscillation. So that's how you determine the period of a pendulum. Frequency is yet another term that we usually use when you talk about the period of a pendulum, or rather simple pendulum. Frequency is actually the number of complete oscillations that the bulb makes in only 1 second. Okay, there we go. So by definition, the frequency of a pendulum is actually the number of complete oscillations that the bulb makes in only 1 second. So after defining what frequency is, we now need to know the units in which we can use to measure frequency, and these are Hertz. Hertz is a unit, or rather the SI unit for measuring frequency, and this simply means that if we have 2 Hertz, it simply means that there are 2 complete oscillations that were made in 1 second. The same can be said if we have 5 Hertz. This simply means that we have 5 complete oscillations that were made in 1 second. Now we can calculate the frequency of a pendulum by simply stating formula. This formula is as follows. So that's our formula in which we can use to calculate for frequency, where small letter f is the frequency of a pendulum measured in Hertz, and the n is the number of oscillations made by the bulb, and the t is the time it takes for the bulb to make a particular number of oscillations. So in order to determine the frequency of a pendulum, you need to know how many oscillations did the bulb make in the question, and you need to know the time that it took for those complete number of oscillations. So that's how you can determine the frequency of a pendulum, by simply saying time divided into the number of oscillations. So frequency and period are inversely proportional to each other, where frequency is the inverse of period, or vice versa. We can simply say period is also inverse proportional to frequency. In the event or situation where you're calculating for period, you need to know the frequency, and it's as simple as that to calculate the other variable. So if you're calculating for period, you need to know the frequency in order to calculate for the period. So this is what we mean by inversely proportional to each other. So by that we mean when one variable increases, the other actually reduces. So that is what we mean by frequency being inversely proportional to the other. So now we are going to step into an example to see how we can determine the period and the frequency of a pendulum, and then explain the factors that affect the period of a pendulum.